People, welcome to week 13, and I know that you've been hanging in there. It's been a little rough. You all have been doing great. Honestly, it's been inspiring and impressive, and keep up the good work. So we're all going a little bit stir crazy here. I know I am, sitting in my basement all day, every day, and so you know what I'm going to do? I'm going to get a little nutty. I'm going to wear this hat. I'm going to wear this hat, and you know what else I'm going to do? This is a can of store-brand SpaghettiOs. I'm going to eat it right out of the can. I'm going to eat it right out of the can while I tell you about how we're going to end the semester and what's going on in this class. All right. Well, now my spoon is too big. So, how is this going to end? I am not going to give you a final exam. I am not giving you a final exam because this is not the semester to give you a final exam. What we're going to do is during finals week, I'm going to take you on a virtual field trip because you all could use a little bit of nature. And I'll give you a little 10-point activity to do with that. I'll show you a video of a virtual field trip, and that's how we'll do that. So for this week, I have a lighter week for you. I only got one thing I want you to do, and you're going to start out by watching this video on topographic maps and follow the instructions on that, okay? All right, people. And by the way, I'm not doing this just to gross you out. I actually kind of like cold SpaghettiOs right out of the can. All right, here's the video. Hey people, Topo Man here. First thing let's talk about is the word topo. T-O-P-O is short for topographic, which means shape. Topographic maps, which is what we're going to study, tell you about the shape of the land and what it actually physically looks like and how tall things are and where the valleys are and things like that. All right, ordinary people use maps to navigate, to go in their car and drive from point A to point B or to find a building on campus, so on and so forth. Topo people use maps to tell them the shape of the land, and that's what you're going to do from now on, especially in this class. All right, so let's start with taking a look at this. Okay, here's your tax dollars at work. I went to a website called the USGS, that's United States Geological Survey. They have an incredible collection of maps, and we're going to check it out now. So if you go here, click on Maps, Imagery, and Publications, you can download free topo maps. We can do this. We can go here and find Mount Pleasant, Michigan. And when we do, look at that. Here we are. You click on this thing here, and it gives you a whole bunch of options. It gives you topographic maps going, well, Midland, Mount Pleasant 1973, and Mount Pleasant 2011. Great, we want that. Let's download it. And when we do, we're going to find this. All right, you're going to get a zip file, and then inside that zip file is a PDF. Here's the PDF. This is what I want you to see. We're going to zoom in a little bit, and we're going to go to the upper right-hand corner. And when we do, we're going to see that it says Mount Pleasant Quadrangle. Quad for 4. Okay, so it's a square map. 7.5-minute series. More on that in a second. All right, so this is called the Mount Pleasant Topographic Map. Here it is. Look at all this stuff on here. There's all these brown lines. All right, and here's the street map of Mount Pleasant. Let's take a look down at the bottom here. When you do, this is what you're going to see. Let's get a little closer here. What you're going to see is you're going to see a little map of Michigan telling you where in the state it is. And it's going to give you this little grid. What's this for? Well, let me tell you. This is the map we're on now, Mount Pleasant. If you need the map to the north, well, its name is Rosebush. What about the map to the east? That's Shepherd. Okay, what about the map to the southwest? Well, that would be Vestaburg, right? Okay, so these are all the maps surrounding it. Here's a typical thing you've seen. Here's the year the map was made. Here's some more information about it. Let's go up here, back here. Here's what I want to show you. I want to show you this number right here. This is the latitude. This is how far above the equator we are in degrees. These are degrees. Let's zoom in a little closer. These are the degrees, okay? 43 degrees, 37 minutes, and 30 seconds, all right? So that's the latitude of this line. That's the latitude. Remember, latitude are those lines along the globe. So everywhere along this line is, look at that, 43 degrees, 37 minutes, and 30 seconds. Okay. Let's take a minute and refresh our memory about latitude and longitude. Okay, so you got to remember, latitude and longitude are measured in degrees, minutes, and seconds, what I call DMS, degrees, minutes, and seconds. These are not about time. I know we measure time in minutes and seconds, but we also measure distance on a globe in degrees, which are broken into minutes, which are broken into seconds. And each degree has 60 minutes in it. And that's distance, 60th of a degree. And each minute has 60 seconds in it. And that's distance, a 60th of a minute. All right? Degrees, minutes, and seconds on a globe, like we talked about, like you read about in the book. Okay, so let's go back to this map. Here's the whole big map here. And if we zoom back in to our upper right-hand corner, we're going to see that that latitude, which we already talked about, was 43 degrees, 37 minutes, and 30 seconds. Okay, let's write that down. Let's go to the bottom of the map, because the bottom of the map also has a latitude. It's this far north of the equator, 43 degrees and 30 minutes. And so if we take 43 degrees, 37 minutes, and 30 seconds, and we subtract 43 degrees, 30 minutes, and 0 seconds, and I'm putting 0 in there because there aren't any seconds listed there, what we get, look at that, 7 minutes and 30 seconds. How much of a minute is 30 seconds? It's a half, yeah. All right, so there's 7.5 minutes of latitude on this map.
Give me a bomb. A Molotov. It's a coup d'etat. Generalissimo steps up shop. Step on a line. Next on a block. Armies marching through the streets. Trust no shot. Trust will need. Coup d'etat. Coup d'etat. Push from the left and a shove from the right. It's all planned out. We'll do it tonight. Push the president and his wife. We'll hold them for ransom or take their lives. Attack their embassy. They are our enemies. The president, they smoke cigars. Anyone he does not like, he shoots or puts behind bars. Coup d'etat! Coup d'etat!
all programs. This is a radio crash on pirate satellite, orbiting your living room.
Let's go back to our map. All right, we're here, and what I want you to do is I want you to look down here at the bottom where it says scale 1 to 24,000. All right, let's talk about that, because here's what that means. The scale of 1 to 24,000 means that if you had this paper map in front of you, and it's about 2 feet by 3 feet, it's a big map, it's a big piece of paper. But if you had this piece of paper in front of you, and you held out your fingers 1 inch wide, and you put your fingers down on the map, and so you measured out 1 inch with your fingers, that would equal 24,000 inches on the ground. Let me repeat that. You take your fingers and you hold them 1 inch apart and you put them down on the map, you got 1 inch on the map. 1 inch on the map equals 24,000 inches in real life on the ground. So that's what the scale means. It's what we call a verbal scale. So we can use that to calculate distances on this map. For example, go back up to the top here and see where it says Central Michigan University right here. Okay, we're about, right here, and so we'll put a little dot there. And if I wanted to know how far it was directly west until I crashed into the river, past this little bend, let's go right here. Let's go to the word Chip and Chippewa River. And I'm going to put another dot here. And I want to know, well, how far is that? Good question. What we would do is we would measure that with a ruler. So I'm going to try to do that here. Hang on. Okay, so our ruler magically appeared here, and I'm going to take my ruler, and I'm going to use inches, and I'm going to measure the distance between these two dots, from the center of one dot to the center of the other dot, and look at that. It looks like that distance is 4.5 inches. So 4.5 inches. Well, on the map, but how many inches on the ground is that? Well, simple. Go back to your scale, 1 to 24,000. So we're going to take 4.5 inches, and we're going to multiply that by 24,000. That's 24,000 inches on the ground for every inch on the map. So when you take 24,000 and multiply it by 4.5 inches, oh my gosh, how do we do that? Simple. Get out your phone and just do this on the calculator. 24,000 multiplied by 4.5 equals, look at that, 108,000. So 108,000 inches. Now, look, I don't know about you, but I don't go around telling people to walk 108,000 inches from point A to point B. So we got to convert that to feet. How do we do that? Well, let's see. 108,000 inches divided by 12 inches per foot. Well, let's divide that out. 108,000 divided by 12 is equal to 9,000 feet. Okay, that's nice, but still, I'm not going to tell people to walk 9,000 feet from point A to point B. So great, let's do this. Let's do another conversion. We're going to divide that number by 5,280 feet per mile. And when we do that, and let's see, 9,000 divided by 5,280 gives us 1.7 miles. 1.70 and change. Okay, good enough. So almost 1 3/4 miles. All right, so that's the distance on this map in English units. Okay, we measured out 4.5 inches on the map, and because of the scale, the 1 to 24,000 scale, that's equal to about 1.7 miles. Wonderful, wonderful. That's terrific. Let's do it in metric. We're going to flip our ruler, and we're going to go like this. Did you like that little trick? All right. Let's do it in centimeters. Okay, that's, let's see, 11 point, all right, fine. Let's say 11.3 centimeters. Okay, so then we go back to our calculator, and we take 11.3 centimeters, and let's multiply that times 24,000. 24,000. Okay, we get 271,200 centimeters. Completely meaningless. So let's divide that by 100. Why? Because there's 100 centimeters per meter. And I like to do things one step at a time when I'm doing unit conversions. So that's equal to 2,712 meters, or 2.712 kilometers. Okay, 2.71 clicks, not quite 3K. There's the distance in metric. See how much less painful the math was? We made one multiplication and then we just went by tens and hundreds. But we insist on using inches and feet and miles in this country, and so we're just going to stick with that for a little while and just try to ignore the pain. Okay, that's how you use the scale. You're going to want to watch this little segment of scale, maybe a couple of times until you see what I did. If this is the first time you're seeing this kind of calculation, it's going to be like, what's he doing? Why is he doing that? Well, watch it a couple times, get a sense of the pattern, and take some deep breaths. Don't panic, and you're going to be okay. Last thing I want to show you is these brown lines. So you remember in class when we did the Play-Doh and we said, okay, each of these lines is the same distance above the table and all that. Remember that? Okay. The reason I showed you that is because that's what these brown lines do. I want to zoom in on them. Okay. Let's get in here to about here. All right. So, here's Mount Pleasant, here's the post office, here's Pickard Road where this number 20 is. All right. And then I want you to look at this brown line here that has 750 on it. What this means, this brown line, is if you were to walk along this brown line is 750 feet above sea level. Well, how do you know feet? Okay, and how do you know sea level? All right. These maps, these American topographic maps, the brown lines showing you distance above sea level. Okay, we're 750 feet above the beach at the Pacific Ocean and at the Atlantic Ocean. Okay, that's just the rule by definition. All right, so if you walk along this line, everywhere you walk, you will always be 750 feet above sea level. So if I wanted to say, what's the elevation of Pickard Road right before it crosses the river? Well, let's see. It crosses the 750-foot contour line. Check it out. That's 750 feet. And if you look across the river, okay, see this 750? You look across the river, you see where it says Chippewa River. If you look across and you see this 750, here's what this means. It means what you're doing is you're standing at 750 feet above sea level, you're going down, you wade through the river. Why aren't you going up? Well, because the water's going to collect in a low spot. Water responds to gravity by flowing in the lowest spot possible. So if you see 750 over here and then 750 over here, and you see a river in between, you should assume that this is a low spot. So you're going to go walk through, you're going to wade through the river, you're going to get wet, and then you're going to be back up here at 750 feet. Okay, follow this line with me a little further north, follow it north till you get to about here, and you see there's this heavy brown line. And there's more lines and more lines and more lines. We're moving away from the river. So we should assume, I think we should assume that we're getting higher. Well, how much higher? These lines represent vertical space. So you're climbing, you're walking uphill from here to here to here. You keep going uphill. How much? I don't know. Let's go down to the bottom of the map and let's look at something called the contour interval. Aha, right there. The contour interval means that every brown line, it's got 10 vertical feet in between it. Okay, so look up here, all right? Look here, you see this brown line. Well, first of all, it's closed. That's a hill, okay? This hill is going to be 10 feet above this line. So if you stand here and your buddy stands here, you're 10 feet above that person. And look, we're going to go another 10 feet down. And if we walk along this contour line, we're going to get to some body of water. And isn't that exciting? Because now you're standing, this contour line is 20 feet above. Speaking of weird contour lines, let's look at this. You see this one with the little marks in it? These are called hash marks. Yeah, hash, H-A-S-H. Hash marks tell you that you're looking at a hole, all right? You might have had the question, well, gosh, professor, how do you know that's a hill? Simple, it's not got these things on it. I'm standing on a hill, I'm standing in a hole. All right, you don't see these too often, but every now and then. All right, let's look. Oh, look, there's another one. See, just proved myself wrong. How about that? All right, well, let's go back up here to Mount Pleasant. All right, here's where it says Central Michigan University. If we're here, all right, let's say we're here where my cursor is. All right, hold it still so everybody can see it. All right, great. If we're there where that little black arrow is, right underneath the sign, the word Central Michigan University, what's our elevation? Huh, okay. Well, let's see. The light brown line is not labeled, but the dark brown line is labeled, and that says 1800. By the way, there's dark lines that are labeled. Those are called index lines. They tell you what your elevation is. And so the question is, what's our elevation? Well, let's see. It's either going to be 10 feet above 800 or 10 feet below 800. Or maybe 5 feet, because we're in the middle in between two contour lines. We're in between this 800-foot line, and then we're between this one. I don't yet know if this is higher or lower than 800 feet. I gotta get a sense of perspective here. You've probably been saying that for a while. But, all right, let's see if we can figure this out. Here's an 800-foot line that's closed. So that's a little hole, or a hill. And here we got a line in between it, and then we got another 800 foot. Well, let's see here. This is not too helpful. We got to kind of hunt around a little bit, see if we can figure this out. It's pretty flat here. What I want you to notice is, a little sidebar here, okay? See how the lines are right here? Let's zoom in a little bit so you know exactly what I'm looking at. All right, these lines right here in the middle of your screen, see that 800? And then you go down to the river. Aha, down to the river. So we must be going from 800 to 790 to 780, 770, 760 feet. Okay. The contour lines are pretty close together here. That means that they're steeper than they are over here at CMU. All right, where the heck are we here? I'm going to say that we are, this is the 800-foot contour line here, right in the middle of your screen. All right, and I'm moving us so that we're right in the middle of the screen-ish. There we go. All right, and then there's this other contour line. I'm going to say that's a 790-foot contour line, and we're about here. You know what? I think we're 795 feet above sea level. Isn't that great? Okay, check this out. We're back on Google Earth. But here's a nice little thing here. I downloaded a KMZ. It's called NGS Topo US2D, and you can search for that and you can download it. So I'm going to activate that layer. Ooh, it changes color. Why? Well, you'll see. Let me zoom in here. Now, when working with this KMZ, you got to kind of zoom in slowly, otherwise it disappears. It's also depends on your internet connection. But what we're seeing here is a layer, a KMZ layer, that's Topo Lines. Okay, so now it's resolving a little better. Here's a whole bunch of Topo Lines. Now what we can do is we can look at the landscape here. Although if we zoom in too much, we're going to lose it. But what I want you to see here is that these topo lines are mapped onto the actual shape of the land. So you can see, look at this, it's a little hill here. And let's go to the river. Okay. Now, watch this. I'm going to type in the zip code of a place that we've been to before in this class. We did this when we tackled Google Earth before. Okay, here's home. Look at that, there's David's Mountain. Now, we're going to go home here, and we're going to tilt and pan, and the first thing you're going to see, look at that. There's the Franklin Mountains again, except this time they're covered in topographic lines. Let's go over to David's Mountain. There it is. We're going to get close to home here. And look at how the landscape is, well, the lines are blurry, but you can actually see the shape of the land. And there's David's Mountain right there. Okay, so let's do this. Let's untilt a little bit. Let's zoom out so that these lines are no longer blurry. I'm going to go ahead and rotate a little bit here. All right, let's zoom out. Okay, look at this. The top of David's Mountain is 4,444 feet above sea level. That's the little peak, okay? It's that little dot right there. The mountain is basically sort of a cone-shaped. It's like a classic mountain shape. Here is the topographic line that says 4,400. Here is the topographic line that says 4,300. Let's follow this topographic line that says 4,300 here, and over here, and over here, and over here. So we have been the same elevation walking along this line. Now we are at the base of David's Mountain. So what I know is that this line we just followed is 4,300. There are 1, 2, 3, 4, 5 lines above it. What I know about this is that the contour interval here is 20 feet. So interval, again, meaning how much vertical distance is there between lines. So I stand here. I'm going to walk uphill, and when I get to this line, I'll be 20 feet above where I was. I'm going to go up 40 feet, 60 feet, 80 feet, and now when I stand here, I am 100 feet higher than where I was. So I'm going to keep going. 44.20, 44.40, and then to the very top is 44.44. Now, one thing I want you to know, when you are working with these brown lines, and I ask you, hey, what's the elevation of this place? What's the elevation of that place? Your answer has to end in 0. When you are working with the brown lines, your answer has to end in 0. This 44.44 is not on a contour line. That's the very tippy top that's in the middle of that closed circle of a topo line. When you see a number that doesn't end in 0, that means that it's not on a contour line. So, all right, let's go over here some more, where the mountains get pretty rugged. Okay, so we're going to look at this. Okay, let's get rid of the topo lines. All right, here's the mountain. So here goes the road, and what we can see from this landscape is this is pretty steep, and this is less steep. Well, how do I know that? Because when I zoom in on it, I can see the difference between what it would be like to walk up this hill versus walking up this hill. Now, let's put the topo lines back up. Okay, see how the topo lines here, where it's not steep, are far apart, and here where the topo lines are close together, that's really steep. So the spacing between the topo lines tells you how steep a landscape is. So if you look over here, look how far apart these lines are. So this is still, what's the elevation of this line? 4,100 feet. I am still walking uphill. 1, 2, 3, 4, 5. So this is 4,200 feet above sea level. But it takes me a while to go up 100 feet. Over here, it takes me a very short distance on the ground to go up 100 feet. That's a heck of a climb. So if we were to look at the down and the Lost Dog bike ride, okay, here's home. The red line here is the ride. What's our elevation change here if we use the brown lines? Okay, let's put home on this brown line here. Well, what's the elevation there? Okay, well, it's one step below this heavy brown line. Can we find a label on that? Let's follow the heavy brown line. Ah, there it is. Okay, this is 4,300 feet above sea level, so home is 4,280 feet. And again, I got that because I know that the height difference between these brown lines is 20 feet. So 4,280. 4260, 4240, 4220, 4200. I'm going to go down another topographic line. That's 4180. Wow, that's steep. That would be 4160. And I cross another topo line. And then I come back up to... So here I am. I'm at the lowest spot, which you all said was Red Road, and I'm going to go uphill now. And this contour line here is 4,180, and I'm going along the contour line, and then I go up a little bit, back down a little bit, and I'm at 4,180 again. So I go uphill to 4,200. Now, how high am I going? Well, here's another brown line at 4,300. Here's another brown line at 4,400. And wow, 4,500 feet. And then a little bit more. And then I go back down. 4,400, 4,300, 4,280. All right. So this is what topo maps look like. And it's neat to see them superimposed upon the ruggedness of the landscape here. Well, can you try to get it done by the middle of next week? See what you can do, okay? Like I said on the form, I am taking stuff through the end of the semester, okay? I got to get grades turned in by the 13th of May, so try to get all your stuff done before then. If you get buried under stuff, let me know if I can help, okay? And my hat.
Combination style.